Good morning, everyone. So what a glorious day it is today. We had an exciting morning where I was experiencing upload speeds of 18 Mbps. I was super excited. I was texting everyone how good my internet is. And then at 9:45, I logged onto OBS and my internet went back down to 4 Mbps uploads. So we're coming to you live through a Zoom meeting with Tom Killingback there. So thanks, Tom, for letting me ride on your internet. And he will be in the chat today, along with, to make it really confusing, just Tom Squared is going to be in the chat, but admin Tom is going to, I think, not be there the whole time. But Tom Squared in the chat today, so very exciting stuff. All right, I hope everyone's had a wonderful flex week and actually got to relax a little bit whilst doing the assignment, but still relaxing. I don't know how that's possible, but I hope that you did manage to do some socializing and enjoying the nice weather that was during the week. And now we're getting back into it. There's 4 weeks to go. We are more than halfway through the whole term, the whole course. So not too long to go until you are finished, and then the big break. So that is something to look forward to and keep you going. And hopefully you've got nice things planned for the end of the year and socializing, and hopefully things are quite normal. So there we have it. So someone's asked why the due date has been pushed back. So the first day was when CSE decided to maintain their servers, and you all lost any connection to the servers for basically the better half of the day. And then on the weekend, someone pushed a change to our auto tests that wasn't us, and it broke our auto tests. So whilst we were recovering from that, we gave you another extra day. So hopefully you've enjoyed the 2 extra days and they've taken a little bit of pressure off. I'm not sure, but hopefully they have. And we will be giving you a few days break as well before we release the next assignment. So we're not going to release the second assignment straight away. It's either going to come out at the end of this week, the very end of this week, or the very, very beginning of next week. So I don't know if you're feeling that excited about new assignments right now, but it's a nice one. I think it makes good sense. Actually, Tom Killingback spent the weekend doing this assignment, so and he's still smiling, so this is good news. All right, so let's get started with today. And it's been Okay, so it's not me. I'm just seeing those. I'm seeing that live chat and I'm thinking, oh no, it's all over. Sienna, there's no flex week to do the next one over. That is true. The next 4 weeks will be quite busy. So I do encourage you to, use the lab time wisely and use, the help sessions that we're going to have going and all the rest of that. So use your lab time. I'm told that the labs are quite empty-ish, maybe, or not as well attended as they were to start with. They are a great place to ask questions. So please, let's do that. And then that can also spread the load for you as well. A lot of late nights, sleepless nights, probably yes, a lot of late nights and sleepless nights, but you do need to sleep. Please, everyone, you need to sleep well, and you need to eat well, and you need to exercise. Those are very important for your health. And yeah, sometimes, knowing that the big break is coming, although then you have exams, so I'm not really sure. You guys don't have as big a break. So hopefully just this is going to be the big push, and then we can, you can recuperate over the break as well. But yeah, please remember, good sleep, good food, and good exercise, and it really kind of, keeps you going. Because if you cannot find an error and you've been in front of your screen for 5 hours, you're not going to find it. You need to walk away. Just walk away from the screen, okay? because either it's going to end with you throwing your screen out the window or you're just going to get very, very frustrated. So just walk away, have a break, go and do something fun, and then you'll see that you will find, you'll see where the error is. Okay, so let's have a look. Anything in the chat? Provisional exam time has it listed as 1:45 to 5. Oh, that's a bit weird. It is a 6-hour exam. Yeah, it's still a 6-hour exam, Sienna. I'm not sure why they've listed it 1:45 to 5. So it's 1 till 7, I believe, should be around. That's the time that I have. That's the time that I wanted to do that. Okay, yeah. So Tom said it's the way it shows up to you, just so that you can get super confused. But we know that it is a 6-hour exam, but you will need at least 3 hours to do this exam in. So try and do that 3 uninterrupted block. The final exam is set over 6 hours, but it's not meant to take you 6 hours. And please take breaks. Please take breaks. Okay, and then we've got, oh my gosh, someone's going, Christian, Linux on your PC. How exciting. And you'll see your computer will become so much more stable. Amazing. Okay, so the exam is 6 hours long, but it's really a 3-hour exam, but we're trying to account for any tech issues. We're trying to account for you needing to go to the bathroom, maybe having a snack in the middle of it. Who knows how you work, if you work in one. So please just take the time to do that. It will be okay. I promise. The exam is not, there's no tricks in the exam. We are testing you exactly what we've taught you. If you do the labs and if you do the tests, the weekly tests, you are preparing yourself for the exam. But I will be talking a lot more about the exam in week 10, and we're going to have some practice stuff for you. So don't worry about the exam right now. Let's focus on the next 4 weeks, getting through 4 weeks, and then we're going to have this awesome exams. There are auto tests in the exams as well. Okay, so let's do it. Oh, I'm already on the slide. Amazing. Okay, so 1 week ago, in a galaxy far away, we started to do pointers, which you may or not have enjoyed, and we will kind of continue to use pointers, but I'll show you at the end of today, we'll have a look at a really, really kind of, why we do pointers in this course. Really, the main reason for it is to show you how another data structure works, because it just goes hand in hand with it. We also used some useful functions with characters and strings. So we used getchar, putchar, fgets, and so on and so forth, and we'll get more practice throughout the next few weeks using those. I'll try and use them in all my examples just so that you kind of get to see them happening. We also learned about strings, which are just arrays of char, and we looked at command line arguments. So taking things straight away from the command line when you run your program, as opposed to asking the user for input. So hopefully you still remember any of that, but if you've forgotten, don't worry. We will be, using those things as well throughout the next few weeks. So you will get practice to do them. All right, today I was hoping to ease you back into things. I didn't want to go too hard, too strong. So I'm going to try and do it softly, so that we can kind of use today to kind of get our heads back in the zone, back into the session as well. And then we can go from there. So I'm going to talk about multi-file projects today, something exciting, breaking up your projects into a multiple file project. I'll talk a little bit more about that in a little bit. We're going to look a little bit more about memory, and the reason for that is because then I'm going to introduce you, very, very lightly introduce you today, just a soft touch to linked lists, and then tomorrow we will really, really kind of do a lot more of linked lists and really focus on linked lists. Okay, so and then the following week we're just going to do linked lists as well. So we're really going to give them a lot of focus and attention, just like they deserve. All right, a little bit of housekeeping. what we're doing is we are going to be utilizing our labs that have not been so full, and because the help sessions have been very full, with people asking for assignment help, which is fantastic. I'm glad to see that everyone is using these. What we've done is created a few tickets in each of the labs that are running today and tomorrow. And what we want to do is, if you need help with your assignment, you can get a ticket to one of those labs, and you can attend that lab, and you can then see, then you will be seen for some help. So priority is given to those students in that lab needing help with their lab, but any other time we will be looking at assignment help during those labs. So it just gives you another avenue today, tomorrow, if you need extra help with your exam. It's because I'm looking at the screen, sorry, with your assignment. Tom, did you have anything to add to that about our Eventbrite?
Me, Tom, or other Tom?
This is so confusing. Tom, I'm going to call you Thomas, okay? Sorry.
We'll go with Thomas.
We'll go with Thomas. Okay. Does Admin Tom have anything to add, because he's the one that created the Eventbrite? You can pop it in the chat, Tom K. No, that's also unhelpful. Admin Tom. Okay. Okay. Yeah. Okay. So Admin Tom will add anything in the chat if he has anything else to say. So for the next 2 days, help sessions are still running. I know that they've been very busy, so this is why we have these extra tickets available for the lab times. So if you need help today or tomorrow, please grab yourself a ticket, or book in for a help session. We're trying to keep it fair as well. So if your lab is Thursday, Friday, you don't have a chance to ask any questions, feel free to come to one of these labs if you haven't been to a help session and you need help. All right, so that's good. I hope people are getting close to finishing or feeling good about the assignment. Where is the code? I had a QR code there as well. It's gone. Oh, I got overexcited with QR codes today. I'm sorry. The lecture code is located in our usual location under week 7. So we will be, that's where we will be working off today. All right. Softly. Who feels like it would be a good idea to revisit the piece of code we did in week 5 as the last thing we did, which was compare.c, because I know that there was a little bit of confusion with why on earth there were so many pointers. And I saw in the forums people were a little bit thrown by that. So pop it in the chat if you would like to spend a little bit of time going over that. I would be happy to do that. Okay, let's do it. Excellent. All right. Yes, sir. I'm not a sir. All right, let's have a look. Okay, so in the last bit of the lecture, I got a bit overly optimistic, and I did this a little bit of a really complex example of comparing 2 words together or 2 numbers. And it was over optimistic, but that's okay. So a few of the questions that I saw in the forum, and I'm going to go with those questions in particular, because I think that for those students that asked those questions, a lot of you also had the same question, because that would really be the questions that I would have if I were doing, if I was looking at that when I was starting to code. Yeah, okay. All right, so yeah, Daniel said it there. So you spent about 3 hours trying to create a pointer to a 2D array of structs. I need to realize that I can pass the array fine. Yeah, okay. All right, so in the code that we did in the lecture, we were comparing 2 words together potentially. And what I was doing is I was sending, just pointers, because I was trying to demonstrate pointers, but it can get quite confusing, too many stars. You kind of, why are we passing a pointer? Why didn't we pass an array? Well, in actual fact, it is absolutely fine to pass an array as well. There are reasons that you pass a pointer, and part of that reason is, and in this case, it is not really as important to pass a pointer as it is to pass, you can't just pass the array because I'm moving through the whole array. But sometimes when I, hang on, no, we haven't done that yet. We haven't done the arrow, Thomas. Daniel, we're doing it. It's happening. It's happening today, okay? We're talking about dereferencing a struct element and a pointer today. So basically what's going on is, the reason I choose sometimes to pass a pointer is because, for example, when I did that array question and I was swapping the first and the last element of the array, what it meant is I'm not passing a whole array. I don't have to take up all that space. I'm literally passing the two things that I want to swap every time, okay? And so that's one of the reasons why you would use a pointer when I have this specific item that I want to use. In this case here, I'm comparing two words. I really don't need to pass the pointers. I could just pass arrays, which makes a lot more sense, and I think perhaps would make a lot more sense for you and doesn't overcomplicate the problem. So instead of passing two pointers, which, if you remember, when you pass an array name, you're really passing a pointer to that first element, so it's going to decay down. But you can pass just an array of max length. And here people were also confused why this is an integer here when I'm passing in a character. I can pass a char, it's not a problem, but remember that in C, my chars are ASCII values, and that's why it's fine to have it as an int. It doesn't have to be an int. The difference there is the amount of space that I take to save a char versus saving an int. So an int takes up 4 bytes of memory, a char takes up 1 byte of memory. However, in this course, we do not care about efficiency or, trying to minimize, trying to optimize your code, or optimize the memory or anything like that. So it's fine to pass an int or a char, but I absolutely see where you're coming from. An int doesn't make as much sense. So feel free to pass a char. They are very similar when you get to C because of those ASCII values and the way alphabet is stored in C. And so here as well, when I pass a pointer to a word, I can just pass an array as well. It's not, and if I change all of that through, so let's change. So I've changed my definitions. So let me change the definitions here as well. So we've got char here. And here I'll make this an array. And I want you to be able to solve problems in a way that makes the most sense to you. Because when you solve this problem in a way that makes the most sense to you, for example, using an array, you will do it, 10 times, 15 times. And then after that, you may be able to, go further and understand how to optimize that. So please, don't solve it in a way that makes sense. Aditha, I'm confused how you haven't declared the pointer anywhere, but it still works. Okay. I'll explain that in a second. Hold on. Let me just change these so that let me just change these. That's a very good question over there. Let me just change these, close bracket, and okay. I think I've changed everything. Just checking. Okay, so you're asking how I haven't declared the pointer, but it's still working. It doesn't make much sense. What's going on? What's happening? And the reason for that is because when I'm calling the function, let me find where I'm calling this function. I am calling this function over here. Okay, so when I'm calling this function, what I'm sending it is this word to compare variable, or what is it? What's the word to compare? Now, my word to compare was actually an array, okay? It was an array of char, and that array was of max length. And this is what I'm sending it. So if you remember, in week 4, we did this whole thing where I gave you the memory addresses of each element in the array. And if you remember that when I just did the name of the array, it was actually a pointer to the first element of the array. So this is why I didn't need to declare a pointer anywhere, because when I pass this array name, just the array name without any index, what I'm passing is the pointer to the first element of the array. I'm passing it really the whole array, because I'm giving it, if I'm giving it the size, then I'm giving it, it knows how far it goes. But when you pass this, you pass the pointer to the first element in the array. So you're passing it word to compare at index 0. So that's why you didn't need to declare the pointer. Okay, and then Sienna is, what is argv, argc minus 1? Okay, so remember we had our command line arguments, okay? And in our command line arguments, it means that our int main is no longer void if we want to take command line arguments, because it means that we're taking inputs now. And if we're taking inputs, we want to know how many inputs there are and what those inputs are. So my int argc, it counts the number of inputs, and my argv is what stores each of the inputs into it. So each of the elements that I've just typed, command line arguments. So each of the arguments is stored in an argv array, and each one is separated by a space. So if you were to run it, and I think I ran it with and let's do that. Okay, and then so what it means is that I'm now able to take things out here and actually compare them. So I want to compare words, and I'm going to compare the word boo. And this is what it means to be able to take inputs into the function. So now I'm doing command line arguments. So type in a word to compare. I'm going to compare it to the word boo as well. Oh, I haven't got anything. So in this command line arguments, I've got 3 arguments. The first one is always the name of the program. The second one is this words here. And then the third one is boo. So argv at index 0 is always going to be the command name, okay? Then argv1 is your first thing afterwards, and argv2 is boo here. And if you remember, because it's like an array of characters, you can then break it down further into 2-dimensional arrays. So argv1 is this words here, but argv10 is W, argv11 is O, argv1, I've forgotten what I've gotten up to, 2 is R, and so on and so forth, okay? Okay, so I think Thomas is answering the chat, so that's good. So Theo's asked, yeah, oh no, Theo's not, he's answered the question. Thank you for that. Okay, so how is that? Does that make a little bit more sense? And as you can see, I've changed everything from pointers to, to arrays, and everything still works, because in fact, when you pass the array name, you're passing that pointer to the first element. Yeah, argv is actually a 2-dimensional array, basically. It's an array. So argv store the strings, and then if you break it down, a string is an array of characters. So you've got both going on. So that is our compare.c. Please pop any other questions you have about this in the chat as well. I hope that clarifies a few things. Hang on, I think, Thomas, would you like to have anything to add?
Yeah, there was just a question about why we do, when we find str length, we do str length -1. And I think the reason you've got it there is to get the index of the last letter, but it might be worth just touching on that again on line.
I'm like, where is it?
Or right up the top. It's on line 41 there.
Haha, yes. Okay. So I'm really checking for a new line now. Okay, someone's asked what's the null terminating character as well, the /0. Okay, if you remember when you have a string, okay, this is good. We're getting good revision from last, because 1 week flex and it's hard to remember everything. So let's say I've got an array of characters, okay, and my array is something here, and I want to say hello, okay? That's what I want my line to be. What that is actually doing is, if it's doing in an array, it's having an H, or definitely not another H, an E, an L, another L, an O, and then the special thing about a string, okay? A string in C always ends in this null terminating character. This is what allows us to know that it is in fact a string, okay? So the last element of a string is always that null terminating character. And what that allows us to do as well is it allows us to loop through a string, because we know when the string finishes. The string will finish when you can see this null terminating character. So when you declare an array, okay, I've got an array here and I said, I put it in these double quotation marks, the word hello. What it will do, even though it's 1, 2, 3, 4, 5, even if there's 5 characters in the word hello, this array will actually give it a length of 6, okay? Because it's going to make space for this lovely null terminating character. So we really want to, a string should always finish in a null terminating character. That's how we play around with it. Okay, and then here we're checking for a new line at the end of input. So if I have, if I put in, let's say, boo, and then I'm going to have a new line after that, okay? So what I'm doing is I'm saying the last letter is actually going to be string length, word to compare. Now, my string length does not count the null terminating character, okay? So this is actually, if I put in boo, what's it's going to be is B-O-O, and then it's going to have a null terminating character, and then it might have, a new line there as well. That's going to be what it looks like. So when string length returns this, string length actually gives me that there are, how many things are there? The reason I'm subtracting 1 is so that I can get rid of this thing here, okay? So I don't account for this null terminating character. So that's why I subtract 1. Okay. Okay, so anything else? So someone's asked, so we can say for a loop of string while index is not equal to null. Okay, so I know it's quite confusing because there's like null terminating character, then there's EOF, and there's a whole bunch of other stuff that's, that's happening. So each function, even though they all really mean the same thing, they all mean the absence of something, or they all really mean 0 in sort of a broad sense. You use different ones, okay? You use different ones in the different functions that you use. So when you're doing a string, you're going to have a null terminating character. When you use fgets, that's going to read until null. And then when you use getchar, that's going to read until end of file. So you're going to get that combination. C couldn't make up its mind. Well, I mean, kind of, but yeah, look, it's useful to have them as different things. Okay, sorry, I didn't explain that very well. In here, string length does not count this here. It does not count my null terminating character, but it counts my new line. So what I'm saying here is get rid of my new line if I have a new line. So my last letter, okay, this is what it's doing here. I'm going to go through it line by line, and I'm going to do inline commenting. Do not do this in your code, okay? This is just me trying to show you what it's doing. So what's this going to return? My comparison here is going to be 1, 2, 3. It's going to skip this null terminating character and it's going to count this one here. So in fact, this last letter is going to be equal to 4, okay? It's going to count it up. Then I want to say, in the array, is it going to be a new line? So can I see this new line? And if it is a new line at that, and now if you can see, I've got 0, 1, 2, 3, 4. So I'm saying at index, this array, struggling words to compare, no. At index 4, which means is it equal to new line? So is it equal to new line? Because if it is equal to new line, and then now I've got 0, 1, 2, 3, 4. If it's equal to new line, that means I have a new line in there. And then what I want to do is instead of that new line, I'm going to make it equal to a null terminating character instead. So instead, I'm going to terminate that word. So I'm going to get rid of it, okay? And it shouldn't be, it should be a new line here, like that kind of. Did I stuff that up? I'm not very good at counting sometimes when I count. I tried to do a simple word, 3 letters, but still I'm struggling. So the 0 is still there. It's just that string length doesn't count my 0. It doesn't, string length just returns to me the length of that string. It doesn't care about the null terminating character. Okay, should we push on? Okay, let's push on if there's nothing else. Yeah, let's do yeah, we can do another little video about it to explain it as well, because I think it's worthwhile to explain it. And then we can go through, I can go through that in specifics as well, just so that we don't, that we have time to work through multi-file projects as well today. So why is it 4 if it skips the null terminating character? It still counts the null terminating, it's not affected by it. And isn't that going to end up as boo, null terminating character, null terminating character? Yeah, so it's string length skips it because it's a special character that tells us that the string has been terminated. So if you think about string length, think about it, it's measuring just this. It's not measuring anything else on the outsides of it. So we'll put on another little section to explain it. I'll do a little short explanation of how it works again in a separate video, because I think it might be helpful with all these questions. Yeah, so you'll have two null terminating characters, and it doesn't really matter because it just means there's nothing there. Okay, let's continue. Okay, multi-file projects, what are they? Daniel, yes, you can chop up strings by inserting a null terminating character wherever you want to split it. Wherever you want to terminate the string, you can insert a null terminating character. You can insert it in the middle of the word. So maybe I'll include that in that little video. That's a good idea. But there's a lot of cool things that you can do by just shoving around that null terminating character. Okay, multi-file projects. What are they? Why on earth do we do them? What does it mean? So far what we've done is we have been doing everything in our main function. Okay, So what's going on is, we do everything in main, and then we said, oh, we can have functions. So then we move things out of the main and move them into functions. But everything is still in the same file. So it's whatever your file.c is called, that's where you're actually building up your solution. And sometimes, I don't know, your assignments might be, 200 lines of code, 300 lines of code, 400 lines of code, depending how you're making your solution. But, it's starting to look very, very long. You scroll through it. You're not really sure where anything is, where each function appears. How do you, actually, read it nicely, and so on and so forth. So cue the multi-file projects. And what happens is that big programs, because if you think you go out to industry, well, 300, 400 lines of code is actually not that much code at all. You've got thousands of lines of code, okay? You've got separate modules as well. You've got things that work together. It is, there is so much happening that you really want to be able to sometimes make your programs more modular. And so you have these multi-file projects because you want to spread your big programs over multiple files, okay? So first of all, it will improve readability. Daniel's saying he's got RSI from the scroll wheel, so it will definitely help you somewhat with your RSI, because it will hide away some of that, functionality that you don't need. You can separate your code by particular subject, which means you can create modules. So what that means is, for example, let's say like the Word document or whatever else, you might have editing things, and that can be one module. And then you'll have, the shape drawing things, and that can be another module, and so on and so forth. So you can have related components separated out. And what that means is that different people can work on those modules. So this is what we really want to have, because often out in the real world, you're not going to be, a cowboy doing your own thing. You're working as part of a team. And a good way to break up the work when you're part of the team is to have these type of multi-file projects where people work on their own modules, and you can test those modules separately. You can write them separately, and then you bring them together and you test it, how it all works together as well, which is, quite exciting. So, so far you've broken functions outside of your main. Now you're breaking it up into separate files as well. So you're creating modularity, and you're making it much easier to read. So yeah, Neil, you can call functions from other files in your current file. Absolutely. So, it's just going to be like, we're just going to be calling across modules and functions and files. You're going to feel like you're like a wizard of C. Just doing so many things. So it's going to be pretty exciting, maybe. And your assignment 2 is going to use multi-files. But don't worry, we're going to help you to get familiar with them. So tomorrow as well, I'm going to break whatever I'm doing into multi-files, and, maybe even the following week, if you want me to, I'll break up anything I do into multi-files as well. So, we'll just keep practicing how to do them. Feels weird at first, and then it just becomes second nature. So you've actually already been using multi-files without even knowing. Every time you hash include a standard library from C, you're using that whole multi-file functionality, because you are saying, include this header file that has these functions elsewhere, and, please, I'd like to use them. So, you can also hash include your own things as well. So super exciting. And what it allows us to do is it allows us to join projects together. As I said before, multiple people can work together on projects out in the real world, which is, quite a solid thing, because you really kind of want that. And what it also means is sometimes these modules that you create can be used across other projects. So some of these functions are relevant for other projects that you might do. So you've got like reuse of code as well, which is pretty cool. Okay. So what is going on? How does it break itself up? Okay, you've got something called a header file, and you've got something called an implementation file, and then you usually have your main file. So there's each module has at least two things. It has a header file and an implementation file. And then separately to that, you have your main.c file, and that's the one that calls everything. That's the one that you make all your calls out of. It will usually, in your main.c, you try to now not have sort of any code that really does much, okay? It's just the one that calls things out. It's the one that, you know, does all the magic. And then your header and your implementation files are the ones that actually have all the implementation in it. So, okay, you might have multiple header files and multiple implementation files. It depends how many modules you have. In this course, we're just going to stick with, you know, one extra header, one extra implementation file. We're not going to go crazy. But each header will have its own implementation. They kind of work together. When you're including your own header file, you use these apostrophes instead of the greater than and less than symbols. So that's the only difference of you telling them that it is in fact not a standard library file. It is one of your own header files. So a header file is going to have a few things in it. We'll talk about it in a second. And then the implementation file, which is your .c file, that's the file that's going to implement all the functions you list in your header file. And then main.c is where you make your calls out of. So what it looks like is a .h file will include any function prototypes. So that's where you define what your functionality is going to be, okay? So all your function prototypes go in the header file, any hash defines go in the header file, and what this .h file does, it actually just, it tells the programmer what it is they're doing, okay? So it shouldn't have any code that runs in it. It has your definitions, it has your commentary as well of what each function does. So now you're cleaning up, you know, your implementation file as well. So I should be able to look at the header file, okay? And I should be able to see straight away what functions you will have and what each of them do. And I don't need to look at the implementation file. That means you've abstracted that knowledge away from me. I don't need to know how it's implemented. I only need to know what it's doing. And then you make calls to all of these functions from the .c file, main.c file. Okay, then we have our .c file, which is the implementation file, and that's where you're gonna actually implement all the functions that you have defined in your header file. And then finally, you have your main.c file, and that's where you call all your functions from. So let's see it in action. Let's see it in action. Let's do an example, and then you can see actually what on earth is going on. Okay, so I've created a maths module. I don't know why, I just felt like that was a good example of it. And I've got a maths.h, a maths.c, and a main.c file here. So maths.h is my header file, and then maths.c is the implementation file. So what you'll notice is good style is to call the header file and the implementation file by the same name. And what that tells me is that this is the header of this implementation file, and then my main.c is just called main.c. And so when I run it, things are just going to go from main.c just as it does in your normal functionality. So someone's like, how did you make a maths.h file? Is it like, yeah, I just exactly the same way as you make a .c file. So I just opened to get it and I saved it as a maths.h instead of saving it as a maths.c. So this is a header file for the maths module example. The header file will contain any hash defines and any function prototypes and any comments of those function prototypes. So let's say in this header file, I want to be able to implement, again, I'm over commenting because I'm trying to write, what's going on. Okay, so I want to be able to implement, let's say, squaring a number. Yes, so your header file and your implementation file must be, and your main file must be sitting in the same folder for it to know what's going on. So same directory, absolutely. That is such a great question. I'm so glad that you're kind of seeing that, yeah, hang on, they surely should be together. They want to be together. Because they're related to each other. I want to be able to implement squaring a number or even swearing a number. That's maybe how people, exactly what is swearing. It's like a polite version of swearing for week 7. So I want to be able to implement squaring a number. What else should we do? What other maths functionality do we want? Should we do a sum numbers? Let's do a third thing. Why not? Let's do circumference, because that will give me a chance to hash define something as well. So let's do a circumference as well. Okay, so let's say square watering. People are just strong on their assignment train now. Or people want to square root. Oh gosh, I hate taking square roots, because then I need to include the maths library really from, well, we could do a square root. Let's start with these three, and then we can add a square root in as well. And you can tell me what, how we can add a square root in. Okay, so first function is going to be squaring a number. And this is going to be my prototype here for calculating a square. I really am obsessed with writing square, not square of a number. Okay, so that function is really going to have, yeah, Tim, so when you're including your own file, no, it should be a little h. It's, yeah, it should be a little h, always a little h. So when, what are my inputs if I'm squaring a number? Well, I want a number to square, I guess. And what's going to be, again, don't know why, I'm loving that W today. And my output is going to be the squared number. Okay, that was a conscious effort to write a Q there, not a W. So that means my input is an int. I don't need to make that a comment. My input is an int. I'm going to call my function square, and I'm going to give it an int as well. So that's my one prototype. Now let's say I want a prototype that sums some numbers. So next one is sum numbers. The sum of two numbers. And again, that means my input will be two numbers, and my output will be the sum of those two numbers. So again, I have an int as an output. I'm going to call it sum just for something creative, and I'm going to give it two numbers to sum. So int number 1 and int number 2. Okay, and then I want to do a circumference. What's the circumference of a square? Of a square. I mean, I hope you don't do a circumference of a square. What's the circumference of a circle? Daniel, what a good question. Would struct definitions live in here too? Oh, that is a really good question. And I will be answering that. Not yet, but I will be. Okay, so 2 pi r, which means I really want a pi, and I really do want a pi. Maybe that's a lunchtime special. So what I'm going to do is I'm going to hash define, and I'm going to hash define a pi here, and I'm going to define it as 3.14. And now I'm going to do my circumference, and it's going to be my prototype for circumference of circle. So my input is going to be the radius, so it's an int, and my output will be the circumference. But what's it going to be? That has to be a double, doesn't it? Because my pi is a double. Okay, so then I'm going to define it, returning a double. I'm going to call it circumference because that makes sense. And I'm going to give it a radius. So that's going to be my input into it. Okay, so what that means is I've defined 3 functions that I now want to do in my implementation file. So I'm going to save this .h file. Now this is now going to give me a lovely definition file. And now I'm going to go across and I'm going to try and implement these functions. Okay, so my first, I'm going to be a bit lazy. I'm just going to copy and paste that into maths.c. Okay, so these are the 3 functions that I want to write. Okay, so the first thing I want to do is I want to include that header file where my definitions are happening. okay? And to do that, what I do is I do my usual hash include, so I want to include something, but instead of using greater than and less than symbols, I use for standard libraries. And the reason I use these is because then it doesn't have to be, they're using standard libraries, so it's about placement of them. I use apostrophes to say what I'm going to do. And it's going to be the maths.h file, which is exactly what my header file is called. So I've told C that actually all my definitions live in this header file here in maths.h. So I've included it now. And now what I want to do is I want to actually build these functions. And let me bracket here. Okay, so a square, I give it a number and I want to return that number squared. So I'm going to return number times number. And in my next one, I'm going to do a sum. So what I want to return is I obviously chose very easy functions because I'm not, I want to demonstrate how it works on the multi-file. Okay, so the sum, return number 1 plus number 2. And then circumference, I'm returning 2 times pi times radius. Okay, so that's going to be my implementation. I mean, super exciting. Yep. Okay, so now we've got, and as you've noticed here, I haven't put any comments in here now at all, okay? All my comments are now sitting inside my .h file, unless I have comments for a particular implementation. But obviously here I'm returning very simple things. I'm not going to really need to comment any of that. The reason for that is because when we're doing our programming, we look at our header file to see what it is that we need to implement. Okay, so our header file becomes kind of like our that's the rule book that we follow. That's the one that kind of gives us the instructions. So what are we actually trying to do? And any details around that. So your header file has all the definition in it, okay? So that's why you do all the comments in here, because this is the one where you're actually saying what each function is doing and perhaps the purpose of each function, whereas in here, you're just implementing it. So you're trying to kind of abstract that implementation away. This is just where someone goes off and implements things. So when out in the workplace, you might be given a header file which has all the functions that someone wants to do, and someone has, devised what would be the inputs and the outputs and so on and so forth. And your job is to go and implement those functions. And that's the reason why all the information, what you need to do, goes in the header file, because that's your rule book that you're going to follow to implement something. Okay, and now let's go to main.c, and in main.c, we're going to make some calls out to our functions, okay? So let's do that. So now, if you see here, we've included our standard library because we're going to be printing something out. So we need to include the standard library to print out or scan something. But we also need to include our header file, because the header file is the one that tells it where all the function prototypes are. And usually in our file here, we would put all the prototypes. So instead of that, we're including our .h file, because that's now going to go and include all of this from here. It's going to include that, it's going to include that, and it's going to include that and that when it compiles the code. So, just another way to do it without writing everything in the one file. Okay, so we've included our header file. So now let's do our main. Or we could enter argc, argv in here. Let's just do it simple first, and then we'll take a break, and then we can shift things about. Okay, I'm going to say int number. I'm just going to not scan in any numbers just to demonstrate what's going on. Okay, and then we can do a few different things just to show you what's happening. Okay, I'll do 15. Oh, why not? Let's do radius, or even a radius. Radius is equal to 5. And now let me call some functions. Printf, and in here, I'll do the square, obsessed with that W, square of the number Percent D is percent D, new line. I'm about to go, yes, okay, there's very good questions in the chat. Let me look at them for a second. Okay, so excellent. Thomas has answered Lisa's questions. Why do you use quotation marks instead of those funny braces? So when we're including the standard library, okay, we use the greater than and less than symbols, because when you put C, like on your computer, when you're using it, the standard libraries come along with C, okay? So what that means is that it goes and it knows where to search for the header and the implementation files for those. But when it's your own file, what you're saying is it's all going to be sitting in the same folder, which is why you use those apostrophes, okay? And that's why you need to use the apostrophes as opposed to the greater than and less than symbols. So standard library is in greater than and less than. Anything that you do, any module that you define is in apostrophes. Okay, and then there was another, how come we don't include maths.c? Another great question. So very good question. And the reason I don't need to include maths.c is because in maths.c, I include math.h, and in maths.h, I don't include anything. But have you ever seen including a .c file? Okay, so you never include .c files, but you always compile .c files, okay? The header file is the one that defines what's going on, and the header file is saying these are the functions that exist, okay? So you are listening to the header file, and when you compile, you only compile your .c files because you're including your .h files. So you don't need to include the main.c because it's sitting in the same folder. And when you include the maths.h, you are telling your file that the other implementation things exist. Okay, so let's, so I want to, okay, I'm going to go number, really struggling with spelling today, apologies. And then I'm going to call the square function. I must be tilted the way I'm sitting. With number in it. Okay, and then let's do the next one, which is the sum. And let's send it number 2. And which function am I calling? I'm going to call the function sum, and I'm going to give it number and number 2. And look at me going over the line. Bad style there, bad style. We'll fix it after the break. I just want to show you this, and then we can have a little break. The circumference of circle with radius %d is %lf, because I'm returning a double new line. And what am I giving it? I'm giving it a radius, and I'm calling the function circumference with radius. There's a number of things I can do when it goes over the line. I can do that. I hate doing that, or something like that. Okay, let me save it. Okay, and now let me show you how to compile it. Okay, when we're compiling things, I'm in the wrong folder. Let me exit out of this one and go into week 7. Yep. Okay, so when we compile anything, we are using, we're compiling all of our C files. So in my case, I have a maths.c and a main.c. So I would do DCC, maths.c, main.c. So I've compiled both my C files, and then the same thing, I'm going to call my, compiled program maths. Okay, I'm going to compile it, and then I'm going to run it. So I'm going to run maths the same way as I normally do, and it's giving me it's giving me all the answers as I would want to do. Any questions? So how far over the line? It's 80 characters over the line. You shouldn't go more than 80. So I would, you know, I hate doing this as well. Oh, it's because I insist on writing long sentences. So you can, yeah, you can do printf functions over multiple lines, or you can break it down in other ways as well. Yeah. Yeah, so they've got to be in one folder, and then you compile your .c files. You don't need to compile .h files because you include them in your .c files. All right, let's take a few minutes break, and then we will come back for a lot more excitement. So let's have a little break. Okay, fantastic. So we're back, and people have been asking some really great questions about the order as well. So if you noticed, I compiled it maths.c, main.co, maths. You can compile that in any order you want. I can go main.c first, then maths.c. And remember that the O flag, it says what the output file should be called, okay? It means you're naming the output file, and I'm going to call it maths. You can call it whatever you like. It doesn't have to be called maths, but I'm just saying the name of it, and then I can run it, and it doesn't matter in which order, as long as you're compiling all the C files. They can be in any order whatsoever. If you skip a file, so for example, if I forget to compile one of my .c files, and then you try to run your main, it's going to yell at you a lot because it won't know what functions you're using or where you're going with this. It won't make any sense, okay, because you'll be missing those extra functions that you have in the implementation file. The only order that matters is that the flag is before what you're naming it. Yeah, basically. Okay, so someone wants me to try it so they can see me getting yelled at. Sure, let's forget the maths.c. I'm just going to compile the main.c, and I'm still going to call it maths. And it's it's yelled at me. It's really yelled at me. It is not happy with me at all, because it's saying, what on earth are you doing? There is a whole bunch of things in there. I have no idea what it means. What does square mean? Where is this function? There's nothing happening. What does sum mean? There is no such thing. Circumference, what is circumference? It's madness. You've told us to do something that we have no rule book for doing, okay? So this is a result of just throwing caution to the wind. If there are 15.c files like maths.c, do we need to mention all the 15 files? If you are using them, you need to mention them. That is correct. Neil, you can do dcc.o program name.c. I have always done it the other way around, and I found it really hard to ever change. Both ways are completely correct because it's looking for your command line arguments. I just find that this way makes more sense to me because I'm using DCC, I'm telling it what files to compile, and then I'm going to tell it what to call it. But it doesn't matter. You can do it the other way around as well. You can do DCCO maths.c, main.c, and I'm going to call it maths. And it's not liking that. So you see there is some, there is some things that you don't want to do. So as long as you have the flag next to the name, then you're okay. Okay? It's just what makes sense to you. The O means what is the name of the output file. Okay? So as long as that -O sits next to, if you don't specify it, no one's ever shown you this. I'm going to just go crazy. I might as well just show you. If you don't specify it, and you can just compile without specifying it, it's an a.out file, which is just horrible, okay, and it's named horribly. So so if I then ls, you can see it's now created this a.out file. So if you don't have that -O, what it does is it creates this a.out file, and you can run things with this file, but it's horrible. It's not very it's not very readable, which is why we use this .o, because the /o, because the /o is the one that tells it, I'm going to name that output file something. It's not going to be called this a.out business. Caitlin, does compiling multiple files together combine them or not really? Oh, what a lovely question. That is a great question. The header file, what it does is even when we include our standard libraries, it will compile it in the compiled file. It will include them at the top in the output file. So it kind of it brings all the header files over to that a.out file, so that output file. So, but I mean, it's not something that you need to worry about really, because C does it all for you when you compile. Actually, not C, the compiler does it for you. Okay, so any other questions? so far about this breaking things up into multi-files? I'll do it again tomorrow. I've got some ideas for tomorrow, and I'm going to break up what we do tomorrow into multi-files as well. So to summarize, and Thomas had this great idea. Why don't I? No, I'm not going to fluke it. I'm going to revise when we talk about it tomorrow again, because I'm going to draw you a box that's wrong and wrong arrow, and it will just confuse you. I'm going to draw it up for you tomorrow when we break it up, which is what's in the lecture notes. I've broken it up again into files, and then I'll draw up a diagram so that you can see how it's broken up. But basically, you include your header file in the implementation file, and you include your header file in the main.c file. So you're including your header file in all your .c files. So you hash include it, and then you kind of go from there, because then that means that it's using those prototypes. It knows what functions there are that exist. All right, and you compile all your .c files. Okay, any other questions? Just pop them in the chat. Okay, so, how unfortunate. I didn't update this slide. I just duplicated it and didn't update it. So now it's listing something that's not right. Okay, this is meant to be the slide. Okay, so let's have a little quick revisit of memory, just in case you thought that, we stopped talking about memory. Pointers are done, pointers are not done. They're only just beginning. But they will become, I think pointers will become a lot more obvious in the next 2 days than they have been so far. So I hope that this will help it to become more obvious as well. Okay, so memory. So far we've talked about variables that are stored in in memory, and where they live. Okay, and so our variables live between the two curly brackets. What that means is if I've got a variable that I have declared in my main here, these three variables are declared in this main. They live for the duration that they are inside my two curly brackets, and they die when they exit outside of the curly brackets. And the reason for that is you got to clear up that memory, right? If you kept them alive even after you've exited the program, what this means is that they are still there clogging up memory, and you are going to at some stage run out of memory if you keep doing that. So some of the control is that any of these variables that I declare, and if you remember, we've mentioned that these are stack variables. They will live and die in between the curly brackets. And if you have your while curly brackets and you've declared a variable inside that while, they're going to live just inside that while, and it's going to die as soon as it goes outside the curly brackets. Okay, so these variables live and die inside the curly brackets. So this means that if we create data inside a function, it will die when that function finishes running. And this is memory that's allocated by the compiler at compile time, okay? So someone's asked, do we talk about stack and heap in this course? Not so specifically that you need to know what the stack and heap are, but I do mention the term stack and heap because I think it's a good introduction for what is coming for you later on when you do more computing. But you need to have a very, very, very basic understanding of stack and heap, okay? So it's not, you don't need to really understand what's going on, but I will go through it. Okay, so basically if we have something like this, okay, if I've made an array in a function, okay, and I've made an array called numbers, it's got 10 elements in it, I've initialized it all to zeros, and then I returned a pointer to the array, okay? But what happens when I get to this closing bracket is that this int numbers actually dies, okay? Because it's a variable that's going to die when it gets to the end of my closing bracket. So in fact, what I've returned now is this pointer to something that no longer exists. Okay, so it's going to be, it's actually going to be rubbish because it's not going to exist anymore. And that is because when I create this variable, it's going to be in the stack. And the stack is really controlled at compile time. So it kind of, it cannot grow and shrink. It grows and shrinks, but it cannot, it's not controlled by me. It's controlled by something else, okay? But there is memory that I can control as well. And I feel always that that's part of the reason that we start you off with C, because C allows you to get a very intimate look at how, you know, what happens when you control memory, things that can go wrong, things that can go right as well. So quite exciting. So if I want to make some memory, if I want to save some memory, if I want to control the memory because I'm living on some power trip that requires me to make memory, and you guys will be using a lot of memory, so you will really just feel like you are either on top of the world, or you will get a lot of bad sections and then it will not feel like you're top of the world. But I hope it will feel like you're on top of the world. Okay, so we have this amazing opportunity in C to actually allocate some memory by calling a special function, okay? And that function is called Malloc, memory allocation. That's really what the function stands for. And what you do when you call Malloc is you tell the computer, or you tell C, how many bytes you want to allocate. And what it will do is it will reserve that memory for you, and it will return to you a pointer that points to that piece of memory that you created based on the number of bytes. So this is another reason why we love pointers, is that they create these really useful ways for us to be able to have an address as a variable as well. So basically, Malloc, you input the number of bytes that you want, and you output a pointer to the address of that bit of memory that you've just created. What it allows us to do is it allows us to dynamically create memory, okay? And what that means is that we can create memory based on our need, as opposed to, you know, when we create an array, you've seen me, you know, doing a hash define, okay? And you've seen me hash define max size 100, 1000, okay? And what that means is when the compiler runs, it allocates, you know, 1000 length to an array. And I might use 2 elements of that array, but my memory is saved for 1000 elements. So what can happen is you can really start wasting a lot of memory there. And whilst in this course, we do not care about optimizing your code, you just can start thinking about, you know, not wasting memory, or how can you have a more sort of optimal solution where you don't need to reserve 1000 spots when you may only use 2 of them. And that's where you use this dynamic memory. So you're in control of dynamic memory. So you've got, you know, it's very heavy weight on you, because you need to be able to release that memory that you've dynamically allocated. Because again, if you remember what I said, when we have our normal code, our variables live, and then they get to the end of the curly bracket and they die. So you don't have to worry about anything. Everything is done for you. Memory is freed up. Everything is great. However, if you malloc some memory, so if you allocate memory yourself, no one is then returning that memory back to the pool of memory, okay? So you need to remember that malloc is best friends with something called free. And what free does is it can return that memory that you allocated back to the pool. Because if you don't free your memory, at some stage, you're going to have quite a memory leak, okay? You're going to have a whole bunch of malloc memory that's going nowhere, that might not be getting used, but it's still there allocated by you, and that can create a memory leak. And we'll show you how to do some memory checks as well, leak checks. We'll do that a little bit later on, but it can create a dangerous situation as well. So, you know, I've phrased it there, you know, be a bit impolite to keep requesting memory and then hog all that memory without giving it back. It would be quite rude, in fact. You know, you've got to keep it humble. Got to give it back. So once you finish using it, you got to remember to give it back, okay? In the past, when I've worked out in industry, if I've ever used Malloc, I will write down on a piece of paper, on a Post-it, and place it on my computer where I've used Malloc, because it is a really common thing to forget to free up the memory that you've Malloced. It's, very common. So always useful to remember that when you finish running, you want to free up whatever you've allocated, because otherwise it keeps living when your program finishes running. Basically, you can free with the function free, and you free the pointer that Malloc was pointing to. Okay, so the pointer that was returned by Malloc, that's what you're freeing. Yeah. So Jess, if you don't free, it's just allocated. I mean, yeah, it will be leaked memory will be freed. It's not to infinity and beyond, but it can cause some really bad problems in that you're keeping a piece of memory. You've kind of gotten rid of it. You try and point to it again, and then it creates. Okay, I'll talk about it because now I'm pointing to things, but I'll talk about it in the next week. But it can create dangerous situations, okay? Because like security issues, basically. When you have this Malloc, you don't free, you try to point back to it again, and it's all a little bit of a disaster, really. So what happens is you basically just think of it like, I always think of memory as like a bit of a grid. And when you dynamically allocate memory, what happens is that it picks from that grid wherever, okay, randomly. It's a heap, okay? That this is really what the heap is. But it's a random grid. It picks random chunks of memory where it's got enough to give you. So what it means is it also gives you some flexibility in being able to take chunks of memory wherever you need them, however big the size is that you need them. And so if you don't free them, you're going to run into problems. Someone's asked, does leaked memory get picked up by the compiler? We do have something that allows you to kind of test for leaked memory, but it's not always, there is a command to check for leak checks, but it's not, you need to be able to keep track of it yourself as well, because it doesn't always pick up everything that needs to be freed as well. But it will basically check that for every Malloc you have a free. That's what it's checking. Yeah. Okay. All right, so how do I know how many bytes I want to give my memory? Okay, because when I use Malloc, I need to specify the number of bytes that I want. So Malloc, I'm just going to write this here, even though it's a sizeof file. But what happens is Malloc returns a pointer to the memory address that you have allocated. And input to Malloc is the number of bytes. Now, I could go crazy and just be like, hey, Malloc, give me 100 bytes, okay? But that will be actually quite useless, because 100 bytes, what kind of that's going to give me some leftover bytes, because, an int is 4 bytes. So if I have, how many bytes, 100 divided by 4, so that means I have 25 ints there. But what if I have chars, then I have 100 chars? It's too random. So when I call sizeof, I can determine exactly how much memory I want, because it calculates the number of bytes that I actually need. Because the point of this dynamic memory allocation is to be more efficient with how we use memory, so as not to waste chunks of it. So we kind of want to be doing it specifically to what we want. So this is really just demonstrating to you this function called sizeof, okay? And what sizeof does is it calculates the size of whatever you're telling it to calculate the size of. So for example, okay, in this one here, okay, sizeof returns a number of bytes. So the size of an int, if I use sizeof and I say to it, okay, give me the size of an int, it will return 4 bytes. You'll notice here that my format specifier is %LU, it's not a D. which you're like, what on earth is happening there? Okay, that's because sizeof returns an unsigned long. It doesn't return a D, percent D is a signed number, so positive, negative number, but a sizeof returns an unsigned number, which is why I'm using this LU, okay? But it's basically just returning a number. Now, what happens if I want to find out the size? I've created an array here just as an example. The array has 10 elements in it, okay? I've initialized it all to zeros. What happens if I want to know the size of that whole array, so of 10 elements, okay? Then again, I just call sizeof and I put that array in there and it will give me the size of that array. It is also the same if I want to do 10 ints, so it would be the same as this. I can also do 10 times the size of just one int. So this makes it really useful if I know I need, 100 of ints, then I can just do 100 times size of int, and so on and so forth. So double, I'll just call size of double, and then size of char, and so on and so forth. And this is just a basic example of how to use size of. I will show you in more detail how we're actually going to be using it. So let me compile it just so that you can see the output as well. So I'm compiling that. Okay, and if I run it, you'll see the size of an int is 4 bytes, the size of an array of ints, so array 10 is 40 bytes, which is 4 times 10 things. The size of 10 ints is 40 bytes also because it's 4 times 10. Size of a double is 8 bytes, the size of a char is 1 byte, and so on and so forward. So you really kind of, have that sort of, okay, so someone's saying, what's percent %LU? Okay, percent %LU is a specifier for a long unsigned number, okay? Because when you do percent %D, your number is signed. That means it has a positive or a negative apparently. But if it's a long unsigned, because memory is not negative, right? So that's why sizeof returns an unsigned number. And that's why I use percent %LU for that in particular. But you should not have many situations where you want to print a sizeof, okay? This is really just demonstrating how sizeof works so that you know when you use it, what it's potentially returning, and so that you can debug your code. If you want to check that you're returning the right thing as well, you can printf and you can use that percent %LU. And someone said, do bigger numbers, bigger words take up more memory? Okay, no, because if you remember, one int is 4 bytes, okay? And that has a certain range of numbers that are allowed to you, 2 to the power of 31, I believe, and then the other way, so symmetrical depending if it's signed or unsigned. But bigger words may take up more memory because you're using arrays to store words in, because a word is an array of char. So it depends what array you've created to store that array of chars in. So have you created a 1,000 element array to store 5 characters? So it depends on that. Okay, and then Lisa, so what would we call the Malloc sizeof to get the exact bytes we need? That is correct. So Lisa is putting it all together, and that is exactly what we would do. We would call Malloc with sizeof together. So let's see it in action, okay? Let's see it in action how we do it. No, you cannot use %D for sizeof because sizeof doesn't return a decimal value. By definition, sizeof is a function that we're borrowing from a standard library, and by definition, sizeof returns an unsigned number because memory cannot be a negative number. You can't have negative memory. I mean, if you were my computer, probably you could try something like that out, but you can't have negative memory. That means it's an unsigned number, which means you have to use the format specifier LU. %D is not going to work for you. And it's going to tell you, no, thank you. That's not going to work for me. So look, just to demonstrate, if I do a %D here, it's going to tell me, no, thank you. That is not really, that's not how it works. You are incorrect. So my format specifies type int, but the argument has type unsigned long. So it's saying to me, your %D is wrong. You need to have a %LU here because sizeof returns an unsigned number. Okay. No, it doesn't convert it. So someone's asked if it converts it, because there is actually quite a bit of difficulty, but what happens is, different computers also have their signed or unsigned as well. You can't predict what that computer will do, which is why those format specifiers are usually so pedantic. Because depends your computer's 32-bit or 64-bit, depends if it's using signed, unsigned. So there's a whole range of factors that might affect what's coming out. Okay, and Henry, does LU stand for long unsigned? Indeed, that is exactly what it stands for, a long unsigned number. So it doesn't have a positive or a negative sign in front of it. Okay, let's see Malloc being used. Oh my gosh, it's 11:40. Where does time fly when you're having fun? I just don't know. Okay, I've moved to partially worked examples though, so that means we will be going well for time. Okay, so I've done an example here of using Malloc and free to put it all together and sizeof so you can see how it works. Don't worry, tomorrow we're going to use more of it. You're going to see it again in action. So don't worry, this is just a soft intro to what's going on. Okay, first of all, and quite important to know, is that Malloc and free live inside the standard library. So when you use Malloc and when you use free, you need to include this stdlib.h, okay? Otherwise, you're going to get some complaining happening as well. It's not going to work. Your compiler is going to tell you that you've got some issues happening. So you want to include the standard library.h as well, because that's where Malloc and free live. So what I want to do here is I want to create a program that reads an array and then reverses it. Because I don't know, why not, okay? Okay, so let's say I've got something here. I've got my int main. I'm taking the size. I'm asking how many numbers would you like to scan in? And then I scan in a number for that size. So what it's telling me is how big an array I actually want, okay? And now I'm going to allocate the exact space for it. Okay, so let's have a look. So let's say, okay, so now if you remember, Malloc is the function that allocates memory, okay? Malloc returns a pointer to the allocated memory. Malloc takes in the number of bytes needed. So if I'm going to call Malloc, what I need to do is I need to store the return of that Malloc into a pointer. So what I'm going to do is I'm going to have a pointer, let's say it's called numbers, okay? And I'm going to Malloc it some space, okay? So the number of elements of this array is stored inside size. So I want to have size times the number of ints as the size that I want to allocate, because size in this instance stands for however many numbers were taken in. So that's what this size is. And I'm going to multiply it by size of one int. Okay, so if someone's put in they want 5 numbers in here, Malloc is going to return to me 5 times 4. It's going to return me 20 bytes, okay? So what's that saying is I want to allocate 20 bytes and it's going to store it. It's going to return to me the pointer to the first section of that memory, okay? So yes, it is. Yes, it should be sizeof. Thank you. Good notice. Well done. I was like, okay, I've got to point out that its size is because of that size. And I was so focused on, hating myself that I called them both size, and it doesn't make as much sense that I wrote size. So well done. Great pickup. Well done. Okay. So we want to allocate some memory, and we're going to doing size times sizeof of that int, of one int. And the pointer is going to be pointing to the first chunk of memory that's coming. So let's say it's going to allocate, so this is going to allocate 40. Let's say I've said I want 5 numbers. So that means it's going to give me 5 times 4, which is not 40, that's 20 bytes. and it's going to give me the first section of that memory. So the pointer is going to return to me the pointer to that memory space that I've just allocated. Okay, so it's going to return the address of that memory space. Remember that our addresses are just boxes that we create, and our box will have, you know, a memory address on its own. And so that pointer is storing that memory address of that block of memory that I've just reserved. Okay, now it is very easy to just Malloc till the cows come home. What happens if I'm just really annoying my computer? I've been Mallocing all day long, and there's no memory left for me to take. Or let's say I need 20 bytes of memory, but my computer only has 10 bytes left. Okay, so it's very good practice to check that there is enough memory for you to actually take. Okay, so that is something that we like to do. If we call Malloc, we will then check if there is enough space for that Malloc. So has the memory been allocated or it hasn't? Okay, now Malloc returns a null if it's not been able to allocate any memory. Okay, and so if you remember, we've also talked about a pointer that is pointing to null, which means that pointer is pointing nowhere. Okay, so if Malloc has failed to give us memory space, it will return a null because there's nothing to point this memory to. There's not enough happening. So if I want to check that there is enough memory space allocated, I'm going to check if that pointer that has been returned to me, if it's equal to null. Okay, so I'm going to ask if numbers is equal to null, then I don't have enough memory space. What that means is this Malloc has returned, I've called this Malloc, and it's put null in here because there's not enough memory space. So if it's equal to null, then what I want to do is I want to give the user an error and exit out of it. Okay, so printf error, Malloc failed, there is not enough space to allocate. And look at this desperation to be less than 80 characters. Look at this perfection, just on the edge of the boundary. Okay, and then I'm going to return 1 to exit out of it. And that will just exit out of the program because I don't have really enough memory to run anything. So this will be a disaster if I try to then go on, because what that means is I'm going to have no memory, but then I'm going to try to put things in there, but there is no memory there. So I've got nothing to put things into. I can't really run unless I've allocated this memory. Okay, now we've checked for that. So now we want to perform some functions here. So I've got a read array function, which is allowing me to read in the numbers that I want to place into that array. And then I'm going to reverse it. So I'm going to reverse the array, go backwards, so if it's left to right, I'm going to go put the last number as the first number, the second last as the second number, and so on and so forth. And then at the end, okay, look at this wonderful thing. I'm going to free the allocated memory for myself anyway. So I'm going to free my numbers, which was the pointer that's going on. And then I'm going to return 0. Okay, so let's have a look here. So we've got our first read array. And, I've given you this function. How amazing. So to read that array, I'm sending it this pointer, numbers, and that's the pointer to that memory space that I've allocated. So what it means is I've given it a pointer to that first chunk of memory space. It knows what's going on. But then what I also have done is I've given it the size, okay? So it knows where to start because it's got that pointer to the first element, but it also knows how far that memory goes, okay? So I'm starting my index at 0, and whilst I is less than size, I'm going to ask the user to enter a number to scan in, and I'm going to pop it inside my numbers at index I, okay? And because I'm using this address off, I'm popping it straight away into the address off as well, okay? And I'm going to increase my I, and that should hopefully fill up the array with numbers. Okay, so now we just need to finish up this helper function to reverse the elements of the array. And again, I'm giving this function my pointer to that memory chunk that I've allocated. And I'm also giving it the size of the array again, okay? So numbers reversed are, okay? And then I want to list my numbers. So again, I'm going to have a variable, a last, because I want to know the last element, which is going to be size -1 if I start my indexing at 0, okay? So then what I want to do, let me just press enter here a few times so you can see what's going on. Okay, so then I've got size -1, and then I'm going to do my while. And this time I'm going to go last has to be greater than or equal to 0, because I'm going to go in reverse order and load it up into my array. And in here, I'm going to print out the number, and I'm going to print out the new line, and I'm going to do this, and then I'm going to start from the back and print them out in reverse order. And because I'm going in reverse order, I'm going to decrement the counter, because I'm starting from the last element of the array and moving forwards to the first element, okay? And then it's a void, so I don't need to return anything. So that could be the end of this. So let's try and see if it works. I'm going to clear this out so that you can see what's going on. DCC Malloc g.c. Okay, and let's Malloc. Okay, how many numbers would you like to scan? I'd like to scan in 5 numbers. I'll go 1, 2, 3, 4, and 5. And then numbers reversed are 5, 4, 3, 2, and 1. So what it's allowed me to do, and this is a really kind of basic use of Malloc. You don't really need to use Malloc in this case. You could easily do this piece of code without using Malloc as well, okay? So this is not the only way to solve this situation here, but I wanted a really basic example of how to use Malloc, which is why I'm doing it with an array. But what's going on here is we've allocated some memory using Malloc, and we've returned a pointer, and then we're passing that pointer around and using it as an array, okay, because the pointer points to the first chunk of memory that we need. Oh, but I haven't reversed the array, have I? I've just printed it out in reverse order. I did something a lot simpler. I haven't loaded things up into that. Yep, so Neil is saying if we can go over the enough memory again, absolutely. So this is the chunk that checks if there's actually enough memory space there to allocate it. So remember that my pointer can point to something called null, okay? So let me write it as a comment so that you remember, because otherwise it's very transient when I'm saying to you. A pointer can point to null, which means it is pointing to nothing. So if there is not enough memory to allocate, Malloc will give that pointer a null, okay? So what that means, if there's not enough memory, that Malloc needs, it will return a null, and it will be stored in my pointer that's returned from Malloc, okay? So then what I do is I check, is that pointer equal to null? And if it's equal to null, that means that there was not enough memory to allocate, because otherwise it would have a pointer, it would have the memory address of the first chunk of memory that I've given it via Malloc. So it will have null if there was not enough memory, or it will have an actual memory address in there because there's enough memory. So it's returning to me the memory address that I will use, that I know how to access now that I've allocated. So I'm going to check if it's equal to null, and if it is, basically I'm going to print some sort of error and exit out of it because I haven't had enough memory to go on or to do anything with. Aditha, what is the purpose of Malloc in this code? So the purpose of Malloc in this code is, if you've noticed, I haven't created an array in here. So I'm storing numbers into an array, but I haven't created this array with a maximum length, okay? So I've solved this problem using pointers to not create an array of, a fixed length. And and really it's not a great, why do we need to use pointers here? You don't particularly need to use pointers here, but it is a really simple example of how you can use pointers. In fact, if I saw this problem out in the real world, I probably wouldn't use a pointer to solve it because, does it overcomplicate things? But what I'm going to do with Malloc next is going to be a lot more complicated. So in this case, the Malloc, I wanted you to see how to use Malloc in its simplest case, okay? So this is me solving this problem by using Malloc and by actually saying, okay, can you create a piece of memory for me that is, in particular, a number of bytes? Because if I declare an array over here, okay, and this is why it's useful in this question, but I mean, like, who cares in this type of question? If I create an array in here, okay, and then I try to say, okay, in size, printf, how many numbers would you like, and size, I can't then say, okay, I actually want that array to be that particular size. Once I start running, my array is static, okay? I need to give it a length when I start. I need to give it a length when I've declared it. I need to initialize it. So what this has allowed me to do by using Malloc, I have said, actually, I'm going to only create an array of however many integers I need, okay? I'm not going to say, give me an array of 100 numbers and then I'll, maybe fill in 5 of them, whatever. So I have saved memory. I've kind of been a little bit more optimal, a little bit more efficient. But it's not necessarily, the B end, and, you don't particularly have to use pointers in here. But what it's showing you is that now what I can do is, instead of saying I want an array of 1,000 things and that's it, I've just booked out this memory with 1,000 ints in it, even if I only use a few of them. I'm now saying, what's the size? And I'm going to use it to calculate how much memory I actually want. Sienna, great question. What if you don't know how many numbers you are going to have? Okay, you can do something where you allow numbers to enter in. Well, no, you can't do that because you've got nowhere to store them. Let me think about it for a bit. There are ways to do it. Let me think about it. I'll answer it tomorrow, the optimal way to do it. I've got a few ideas, but I don't want to demonstrate it. Richard's saying linked list. Well, linked list would be a great solution to that problem, but I'm trying to think of a different solution to the problem because we haven't done linked lists yet. But yes, a linked list is a superb solution to that type of problem. So you can store numbers in Malloc like an array. No, what Malloc does is it gives me some memory. Okay, so Malloc allows me to have a piece of memory in my computer. It doesn't store anything inside Malloc. Malloc returns a pointer to the memory that it's created. So, let's say, you know what? Here we go. I'm going to go crazy. I'm going to draw a quick diagram. Hold up, wait a minute. Here we go. Okay, that's not, I don't want to do that. I want to do a blank. Okay, so basically what's happening is, yeah, so Tom's got a good one. Malloc builds the house, the pointer stores where the house is, and we dereference the pointer to go to the house and put something in it. And what actually happens is, let me move this thing. Okay, I'm gonna go over here. Okay, so let's say I have this giant chunk of memory, okay? I don't know if you can see what I've drawn this black square. I'm not sure you can see it. There's a little bit of a buffer. Yeah, there it is. Okay, so let's say this is a square of memory, and then I said, hey, Malloc, help me out. Give me some bytes. Give me 8 bytes. And Malloc will be like, okay, where have I got 8? I'm going to give it here, okay? I'm going to give you this bit of memory here, and let's say this memory is this. So Malloc has now reserved these 8 bytes here for me, and what it's doing is it's returning to me this address. It's telling me where it's reserved that memory for me, okay? So Malloc is what's building the memory up, okay? And then the pointer is what's telling me where that memory is that's been reserved for me, because otherwise, you know, there's a lot of memory everywhere else. How would I know where to find it? I do not. So what happens is Malloc builds the memory for me, or as Thomas said, builds the house. It's a great analogy. And then the pointer is the address of that house, okay? So the pointer is where is that chunk of memory that was reserved for me? And then we can dereference that memory by saying, go to this place. Okay, so we're going to finish there for today. Thank you for, hang on, let me do, if you have any, okay, I haven't done the structs, I'll do that tomorrow. Don't worry, we are, okay, any feedback? Oh God, it's gone past. Okay, any feedback, let me know. But we will do a bit more tomorrow, and we're gonna look at linked lists in a bit more detail tomorrow, but I really wanted to go softly today, so as not to just throw you all under the bus after you've had a nice break. So thanks everyone, thanks for tuning in. We will see you tomorrow, yeah, for more excitement, I suppose. All right, I'll see you tomorrow, bye.